Well, dear students, actually I want to start Carnot engine. So first of all, we have to understand what is the meaning of reversible engine. Actually, it is trouble with us that we start learning without understanding. I have told you heat engine has three parts: the hot body, the cold body, and working substance. And here the working substance. In every and heat engine work in a cycle. In every cycle, some heat is taken by the working substance, converting some heat into work, rejects the remaining heat Q2 to the sink and returned into, and then after giving heat Q2 to the sink, it returned back to the original state of working substance. Working substance returned to the original state by, I am telling here that this working substance take heat, certain heat Q1, converting part into work, rejecting the heat Q2, it return back to original state. In this condition, the condition of hot body, cold body may change, or surrounding also change. But if we traverse this cycle in reverse order in such a way that the working substance return to the original state and no changes are left in the hot body, cold body and working substance, then the engine is called reversible engine. I told you, okay, in a heat engine, working substance go through cycles, and each cycle it take heat from the hot body, converts a part of that into work, and gives out rest heat to the cold body return to original state. During this cycle, the condition of the hot body, cold body, and surrounding change. Please try to understand what I am saying. In heat engine, the working substance take heat from hot body, converting part of that into work, and by rejecting the remaining heat, the working substance returns to original state. But in this cycle, the condition of hot body, cold body and surrounding changes. So that way, if such engine we have, that is not reversible. But if we can perform the cycle in such a way that in reverse order, that no changes are left after the cycle in the condition of working substance, hot body, cold body and surrounding, then engine is reversible engine. बहुत जरूरी है ये समझना कि व्हाट इज रिवर्सिबल इंजन. तो हियर I have told if this cycle can be traversed in reverse order such that all the parts of engine completely recover original condition and no changes are left in the surrounding, then cycle is reversible cycle and engine is reversible. I have told you in the last video the reversible and irreversible cycles. So this is a concept only. Only reversible engine will be there if all parts are free from dissipative forces like force of friction, viscosity, etc. And the pressure temperature difference of the system and surroundings are negligible small, which I have told you that both quasi-static state, but quasi-static state does not exist. So it is the only a concept. Practically, reversible engine does not exist. So based on this concept, Carnot developed a cycle or developed a heat engine which is called Carnot heat engine or Carnot cycle. So I will take now here Carnot heat engine, that is a reversible engine, and we'll try to understand how the efficiency of heat engine may depend on temperature of hot body, cold body. So Carnot, actually here the word is N-O-T, T silent, which is spoken as Carnot heat engine. It is purely a theoretical idea about the working of heat engine, reversible engine. Carnot engine is a reversible heat engine which operates between two bodies which are at different temperature. The body at hot temperature is called hot body and the other cold body. Carnot cycle. First of all, I take Carnot cycle or engine has four parts. Number one, a hot body. A hot body or source of heat at high temperature. High temperature, say T1. Number two, cold body or sink at low temperature. Say T1, T2. Working substance. Working substance. I will tell you what is working substance. And number four, insulating stand. Insulating stand. So here, these are four parts of insulating stand, that is bad conductor of heat or stand. Stand which is perfectly a bad conductor. Topic is rather lengthy, it may take two videos also. We saw the working substance here. Working substance here is ideal gas which is enclosed in a cylinder having valves bad conductor, piston bad conductor. These dotted lines indicate that the valves and piston are bad conductor and some weights are placed on it. just to have pressure constant. Here is the ideal gas. Ideal gas. Now, hot body. Here is a hot body at empty one. This is symbolic diagram, nothing else. Symbolic diagram, hot body. Actually, in class 11, this has been made optional topic, but in competitive exam, NEET or AIEEE, there will be 100% a question on Carnot cycle, insulating stand. And this is the sink or cold body. These are four parts of Carnot engine. Carnot engine. Actual name is Carnot engine. The hot body, source of heat, maintain at temperature T1, and the hot body is such a body that on taking heat, temperature does not change. So this is theoretical idea. Insulating stand and cold body or sink. So this is the, now to understand the working and efficiency of this engine, we imagine that this gas, this cylinder can be placed on the hot body stand and cold body without doing any work. Without doing any work, the cylinder can be placed or can be moved from hot body to insulated sand and then sink and then insulated sand and hot body without doing any work. So, suppose now working, we have to understand working. Rather a lengthy process here. Suppose ideal gas is at temperature T1 and now we place it on the hot body. The area of base, this basic conductor, dimensionally is the same that surface area of hot body. So now putting the cylinder on hot body, they are at same temperature. So nothing will happen. But if we change the mass, this weight here slightly, we decrease it, then gas will try to expand because pressure has reduced. And when gas will expand, it will do work. Since the internal energy totally depend on temperature, so temperature will slightly decrease from hot body, so it will take heat. And the expansion is allowed to certain extent isothermal because temperature of gas remains same. And then we put, after certain time, we put the cylinder on insulating stand. When the cylinder is placed on insulating stand, base become bad conductor, and now we remove the remaining weight and gas is allowed to expand. Since no heat is allowed to come in nor to go out, the expansion will be adiabatic. And we allow the gas to expand till temperature become cold body. Because you know, in adiabatic expansion or compression, temperature of gas will change either by doing work. By when the system will do work, internal energy will be used only to do work. And when we compress, so work will done, internal energy again increases. So when we place here And now we place the weight. So gas is compressed. Since temperature has become T2, now when we compress, the temperature will increase and heat will be given. And we compress it to certain value and then bring this on the insulating stand and place the whole weight and allow the gas to compress till temperature become T2, T1. So this is a process here which we can represent on PV graph. For the exact process you can read the book, different books are there. There is one book with V. Newton Physics. So it is very well described there. So initially the gas is at pressure P1, volume V1, temperature T1. So this is the state A. Here pressure P1, volume V1. When we replace one weight, it expands both to point B, where pressure becomes P2, volume V2, but temperature remains T1. When the piston cylinder is placed on the whole body and some weight is removed, so gas will expand. Now, after putting the cylinder here on the insulating stand, we remove this remaining weight. So it will further allow to expand till temperature becomes equal to sink. Whole body, so it is here. C point. Here pressure P3, volume V3. And temperature becomes T2. BC is adiabatic expansion. Now we bring the cylinder on sink. Temperature become here T2. And then place this weight here, one weight only. And compress the gas. When gas will be compressed, some work will be done on the gas. Temperature will become slightly more than T2, and hence it will reject heat to the sink. And suppose the expansion is there up to point D, where pressure P4, volume V4. Pressure P4, volume V4. This is point D. Now, when after point B, we bring again it on insulating stand and place the remaining weight and allow the gas to compress till temperature T1. So this is here the Carnot cycle. It takes place in T2. This is here point A dash, D dash, sorry. It is A dash. It is C dash. It is C. So this is our Carnot cycle represented here. You can prepare a note of this, but basic facts which we have to understand will be explained here now. So I think you have got the procedure. Okay, first, initially the ideal gas is at temperature T1, pressure P1, volume V1. We place it here and remove some weight gently, and when we decrease pressure, the gas will expand. And during expansion, the gas will be doing work against some pressure, temperature will decrease slightly, but since it is in contact with hot body, it will take heat and we allow it to expand from P2 up to P2, V2. Now we place it on insulating stand and remove the remaining weight and allow the gas to expand adiabatically to C till the temperature of gas becomes equal to sink, and then place it on sink and place some weight, one weight, and compress the gas to point D. Here become P4, V4 and so on. And then we bring it back on the insulating stand, compress and initial position. So this is a reversible cycle. Now we want to calculate the efficiency of Carnot engine. The main point is that main point here is that we want to calculate the efficiency of heat engine. I will do it in next video. Please see that because it will take lot of time. In next video, I will take here a derivation of efficiency of heat engine. Thank you.